The late glacial maximum, or Tardiglacial, is defined primarily by the beginning of the modern warm period, in which climates in the Northern Hemisphere warmed substantially, causing a process of accelerated deglaciation following the last glacial maximum. At this time, human populations, previously forced into refuge areas as a result of last glacial maximum climatic conditions, gradually begin to repopulate the Northern Hemisphere's Eurasian landmass and eventually populate North America via Beringia for the first time. Evidence for the occurrence of the late GM stems from two main types of analysis. The first is the use of oxygen isotope stages gathered from stratified deep-sea sediment cores. Samples are gathered and measured for change in isotope levels to determine temperature fluctuation for given periods of time. The second is a proxy measurement, namely, the observation of certain reappearing fauna and flora fossils that can only survive in temperate climates, thus indicating warming trends for a given geographic area. Archaeological evidence of settlement and resettlement in certain areas by humans also serves as a proxy measurement. Towards the end of OIS2, in which the late glacial maximum occurs, the deep-sea sediment cores indicate a gradually warming climate, and the reappearance of certain warm weather flora and fauna remains throughout the Northern Hemisphere correlate with this trend. A period of relatively brief cold oscillation, referred to as the Younger Dryas, is detected during OIS2, as can be inferred from an increase in isotope weight. Western Europe and the North European Plain. Climate amelioration begins to occur rapidly throughout Western Europe and the North European Plain c. 16,000–15,000 years ago. The environmental landscape becomes increasingly boreal except in the far north, where conditions remain Arctic. Sites of human occupation reappear in northern France, Belgique, northwest Germany, and southern Britain between 15,500 and 14,000 years ago. Many of these sites are classified as Magdalenian, though other industries containing distinctive curved back and tanged points appear, as well as the Fennoscandian ice sheet continued to shrink. Plants and people began to repopulate the freshly deglaciated areas of southern Scandinavia between 12,000 and 10,000 years ago. The western coast of Norway and southern Sweden to latitude 65 degrees north becomes occupied by sites belonging to the Fosno-Hensbacher complex. They are defined by the appearance of tanged points and other artifacts similar to those found earlier in northwest Germany. Komsa sites are found about 7,000 years ago along Norway's Finnmark county above 70 degrees north and further east on the Kola Peninsula. They are defined by surface finds of tanged points, burins, scrapers, and adzes. The primary game of Magdalenian hunters appears to have been reindeer, though evidence of bird and shellfish consumption persists as well. East European Plain. Paraglacial lower steppe environments prevail across the East European Plain during this time, although climates ameliorated slightly during several brief interstadials and began to warm significantly after the beginning of the late glacial maximum. Pollen profiles for this time indicate a pine-birch woodland interspersed with the steppe in the deglaciated northern plain. Birch-pine forest with some broadleaf trees in the central region, and steppe in the south. This pattern reflects the re-emergence of a marked zonation of biomes with the decline of glacial conditions. Human site occupation density was most prevalent in the Crimea region and increased as early as around 16,000 years before the present. Reoccupation of northern territories of the East European Plain, though, did not occur until 13,000 years ago. Prior to this, settlement of the central portion of the East European Plain was significantly reduced during a period of maximum cold c. 21,000–17,000 years BP. Overall, little archaeological evidence suggests major shifting settlement pattern during this time on the East European plain. This is unlike what was occurring in Western Europe, where Magdalenian industry producers were rapidly repopulating much of Europe. Evidence of this can be found as far east at Kunda sites located throughout Baltic country territory where tanged point and other tool-making traditions reminiscent of the northwestern European Magdalenian persist. Generally, lithic technology is dominated by blade production and typical Upper Paleolithic tool forms such as burins and backed blades. Kostenki archaeological sites of multiple occupation layers persist from the Last Glacial Maximum and into the Late Glacial Maximum on the eastern edge of the central Russian upland, along the Don River. Epigravettian archaeological sites, similar to Eastern Gravettian sites, are common in the southwest, central, and southern regions of the East European Plain c. 17,000–10,000 years BP, and are also present in the Crimea and northern Caucasus. The time of the Epigravettian also reveals evidence for tailored clothing production, a tradition persisting from preceding Upper Paleolithic archaeological horizons. Fur-bearing small mammal remains abound such as Arctic fox and paw bones of hares, reflecting pelt removal. Large and diverse inventories of bone, antler, and ivory implements are common, and ornamentation and art are associated with all major industries. Insights into the technology of this period can also be seen in features such as structures, pits, and hearths mapped on open-air occupation areas scattered across the East European plain. Mammoths were typically hunted for fur, bone shelter, and bone fuel. In the southwest region around the Middle Dniestr Valley, sites are dominated by reindeer and horse from the last GM to the late GM, accounting for 80 to 90% of the identifiable large mammal remains. Mammoth is less common, typically 15% or less, since the availability of wood eliminated the need for heavy consumption of bone fuel and collection of large bones for construction. Mammoth remains may have been collected for other raw material, namely ivory. Other large mammals in modest numbers include steppe bison and red deer. Plant foods more likely played an increasing role in the southwest region than in the central and southern plains, since southwest sites consistently yield grinding stones widely thought to have been used for preparation of seeds, roots, and other plant parts. Siberian Plane. During the late GM, southern Siberia supported little vegetation, though some trees, mainly pine, persisted. Evidence comes not only from pollen spore data, but also from wood charcoal in former hearths at archaeological sites. Pollen samples around Chukotka and the Taimyr Peninsula indicate a forest zone emerging roughly 7,000 years ago and slightly warmer climates than at the present. The earliest human reoccupation of Siberia does not begin until 21,000 years ago. Evidence of this persists mainly in the south around Lake Baikal, as at the Studeno site, for example. Later sites include Kokorevo in the Yenisei Valley and Chernuza in the Obriva Basin. These sites are confined to latitudes below 57 degrees north and most are C14 dated from 19,000 to 14,000 years ago. Settlements differ from those of the East European plain as they reflect a more mobile lifestyle due to the absence of mammoth bone houses and storage pits, all indicators of long-term settlement. Visual art is uncommon. Fauna remains consist of red deer, reindeer, and moose and indicate a mainly meat-oriented diet. The habitat of Siberia was far more harsh than any other area during the late GM and often did not provide enough survival opportunities for its human inhabitants. This is what forced human groups to remain dispersed and mobile throughout the years. Such is reflected in the lithic technology, as tiny blades were typically manufactured, often termed microblades, less than 8 centimeters wide with unusually sharp edges indicating frugality due to low resource levels. They were fixed into grooves along one or both edges of a sharpened bone or antler point. Specimens of complete microblade insert points have been recovered from both Cocorivo and Chernusa. At Cocorivo, one was found embedded in a bison shoulder blade. As climates warmed further around 15,000 years, fish began to populate rivers, and technology used to harvest them, such as barbed harpoons, first appeared on the upper Angara River. At this time, people expanded northwards into the Middle Lena Basin. By 11,000 years ago, settlement size increased as discovered at the Ust-Balai site, where fauna remains consisted of entirely modern-type remains of deer, moose, fish, and traces of domesticated dogs. New technologies such as fish hooks appear among bone and antler implements. The Diaktai culture near Diaktai Cave on the Aldan River at 59 degrees north are similar to southern Siberian sites and include the wedge-shaped cores and microblades, along with some bifacial tools, burins, and scrapers. This site likely represents the material remains of the people who spread across the Bering Land Bridge into the New World. At 12,000 years ago, the Sumnergan culture appears over large portions of northern and eastern Siberia. These sites are small and yield few artifacts of small blades struck off thin cylindrical cores. Bone tools are absent, as well as fishing equipment. Most Sumnergan sites were located in the forest zone, and because of that, most tools were likely created from wood, which would help explain a sparse archaeological record. Another factor may be low levels of human settlement, since the region of the Sumnergan culture could likely only support a considerably lower biomass than the rest of Eurasia. This is even reflected today along the Middle Lena Basin among current human populations. The Sumnergan diet consisted of large mammals such as deer, moose, and even brown bear, as revealed by the fauna remains found. Nevertheless, Sumnergan culture representatives moved northward and become the first to populate Siberia's Arctic tundra sea. About 10,000 years ago, at around 9,500–9,000 years ago, Sumnergan sites spread to Jokov Island, where slotted bone and antler points, antler and ivory mattocks, and bone handles for cutting tools were found. Few wooden artifacts were also found, including a large shovel, a scoop, arrow shafts, and a sledge runner fragment. Fauna remains consist of reindeer and polar bear. Only isolated bones of walrus, seal, and birds were identified. Further settlement proceeded eastward and westward into Chukotka and the Taimyr Peninsula, North America. Over the land between the Lena Basin and northwest Canada, increased aridity occurred during the last glacial maximum. Sea level fell to about 120 meters below its present position, exposing a dry plain between Chukotka and western Alaska. Clear skies reduced precipitation, and lowest deposition promoted well-drained, nutrient-rich soils that supported diverse steppe plant communities and herds of large grazing mammals. The wet tundra soils and spruce bogs that exist today were absent. Cold temperatures and massive ice sheets covered most of Canada and the northwest coast, thus preventing human colonization of North America prior to 16,000 years ago. An ice-free corridor through western Canada to the northern plains is thought to have opened up no earlier than 13,500 years ago. However, deglaciation in the Pacific Northwest may have taken place more rapidly, and a coastal route could have been available by 17,000 years ago. Rising temperatures and increased moisture accelerated environmental change after 14,000 years ago, as shrub tundra replaced dry steppe in many parts of Beringia. Camp settlement sites are found along Tanana River in central Alaska by 14,000 years ago, and some evidence suggests human exploration at the Bluefish Caves in the Yukon as early as 15,500 years ago. Earliest occupation levels at the Tanana Valley sites contain artifacts similar to the Siberian Diaktai culture. At one point, these comprise mycoblates, burins, and flakes struck from bifacial tools. Artifacts at the nearby site of broken mammoth few, but includes several rods of mammoth ivory. The diet was of large mammals and birds, as indicated by faunal remains. Earliest site occupation at Ushki sites of central Kamchatka display evidence of small oval houses and bifacial points, stone pendants, beads, and a burial pit are present. In central Alaska up the northern foothills at the Dry Creek site c. 13,500–13,000 years ago near Nenana Valley, small bifacial points were found. People were thought to have moved into this area to hunt elk and sheep on a seasonal basis. Microblade sites typologically similar to Diaktai appear about 13,000 years ago in central Kamchatka and throughout many parts of Alaska. Around 12,000 years ago, the rising sea level reached a position less than 60 meters below today's level and flooded the lowlands between Chukotka and western Alaska. The ensuing increase in moisture accelerated Alaska's transition to wet tundra and coniferous forests. The Bering Land Bridge had closed, thus Beringia ceased to exist. About this time, sites that comprise the Denali complex appeared and persisted to about 7,500 years ago. Denali complex sites indicate high yields of caribou remains c. 8,000 years ago and corresponds with an increase in settlement size. Human genetics. The European distribution of Y chromosome haplogroup R1a has been suggested to have occurred as a result of receding glacial activity, allowing males bearing the lineage from the present-day territory of Ukraine to migrate and gradually populate Central, Northern, and Western Europe. Alternatively, it has been proposed that males from haplogroup HGP*R1b repopulated most of Europe shortly after the last glacial maximum, related to population expansions out of the Franco-Cantabrian region. The European distribution of Y chromosome haplogroup I and various associated subclades has also been explained as resulting from male post-glacial recolonization of Europe from refuge in the Balkans, Iberia, and the Ukraine, Central Russian plain. Males possessing haplogroup Q postulated as representing a significant portion of the population who crossed Beringia and populated North America for the first time. The distribution of mtDNA haplogroup H has been postulated as representing the major female repopulating of Europe after the last glacial maximum. For the Franco-Cantabrian region, mtDNA haplogroups A, B, C, D, and X are interpreted according to some as supporting a single pre-Clovis populating of the Americas via a coastal route.